Now Aaron suggested, why don't we also do study with water to see how Tesla light systems also influences the imprint onto water. So we have water from the lab, to which we have a baseline reading, and then this glass of water was placed alongside the DC frequencies of the Tesla coil and kept over there for now almost it was 11-minute cycle. Then after the 11-minute cycle, it has been now in that state after the system was shut off for another 15-20 minutes. So now we have the glass back in the lab, of which I took a syringe, and in this syringe now we have full headspace of the water that was influenced by the Tesla light. Now it is going in through this sleeve, and we are going to cascade a drop there. So we look right down at the bottom, and we are going to suspend a drop right down. Can you see it? Yeah. And now this drop is going to be just above the electrode, about 1.5 to 2 millimeters. And there it sits. We put the cap on the top, and now we come to this screen over here, and in this screen we will begin our capturing of data. So start video file. Here we go. Ready? So here is what we are looking at. This is, and what we are actually now capturing is a continuous, what we call a dynamical image of that droplet of water suspended, and we are doing a 10-second reading at 15 frames per second, and we are going to do this in 5 sequences. We just did sequence number 1, so now we go to sequence number 2. So is again a dynamical cascading of photons and electrons onto the droplet that is providing this image. We take our third reading, and there, the fourth reading, and the fifth reading. So a total for each sequence, when we do such water studies, we get a baseline of about 750 dynamical images of the droplet. Then we can, okay, so now this is done. This is done. We can close this file, and now we can go and look and see what the data is showing us. And this takes us into a program that was also designed by Dr. Korotkov called the Scientific Laboratory Program. This is the baseline water we are gathering. Okay, and we look at baseline water. Now we have again in each of these panels is a 150 frames. So 150 times 5 is 750. So if we want to look at one of them, and we can see that there is a dynamical image of the baseline of the lab water. You see that clearly? Yeah. Okay, so that is sample number 1. And now we go to our sample number 2, and we Teslas and charged water, and we have 1 through 5 open. Okay, and now we have, see, this collective information. Now we will go to a screen where we can begin its calculations. So there will be a total of 1500 dynamical images, 750 from each baseline to 750 of the charged water. So we are going to look at some parameters, parameter of area average intensity. Area is the number of pixels. Intensity is the level of its photon discharge activity. And we are going to look at entropy, so which means it also gives us the activation of what is transpiring with the liquid. So now we go and we put them into calculation mode. Calculate. So once all this took a handful of researchers to sit down and do, and you would get the data maybe about 4 days later. Now you will get the data in about less than 1 minute. How's that sound?
Yeah, that's terrific.
And then once we get this data, then we can observe its various influence, how the Tesla lights influence the water and the information that the water in turn then is providing us based upon these 3 parameters. Okay, so here is one statistical curve. And from that statistical curve, let us look at very precise activity. Number 1, we can see that this is the baseline water of area, and this is the water after the charge. So just to give a value, we can see that the water, the area of the water is very consistent all the way. This is time on the x-axis, and area, which is the number of pixels, on the y-axis. So here we see that a mean value, so let's go like the midpoint here, and the mean value here is roughly about 980, and the mean value after the charge is 2281. So of course, so the glow of the water is tremendously much higher than where it was to begin with. Let's look at one more parameter. What would be the average intensity? Average intensity here shows that the base was about 113, and from 113 it went up to 150. So it's still well beyond the 10%, and so that is again supportive to show that the influence of the Tesla lights has definitely raised the number of pixels, so it has increased the process of informational capture. So the capacity of the water to retain its environmental influence. A key point. Then along with that, intensity, so which is the brightness characteristic, has also been enhanced. Now we look at entropy. So initially, which is the this line, we can observe the flow of, so we can look at the peaks and valleys, and we can see that there's a lot of peaks and valleys going all the way across. Now let us see if those peaks and valleys are minimized or have they been smoothened out a little. And we see that there is definitely a smoothing process that has occurred. You see that, Taran?
Yes, I can.
So here we can see some very clear influence of the Tesla lights to the absorption capacity of the water. Okay, then of course we can go on to various other parameters because there are various other data fields that show, and then we can calculate all this, you see, all this data of calculation for all the 150 frames in each segment all the way up to the 750, and then we look at all the values here. See, each one independent values that are calculated, computed, and now we want to generate a word report. I can go here, click, and I can generate a word report on this study that we just did, and now from there we can come to many inferences.